Welcome to the Fifth Industrial Revolution, and welcome, Dr. Borowitz. My name is Richard Kansal. I'm a professor at the Stillman School of Business, Seton Hall University. I am a late-age professor. I spent 20 years in healthcare before this as a consultant and as a senior exec at Boehringer and Siemens Healthineers. And now I spend my time thinking about our future and also about leadership. Launched this project called the Fifth Industrial Revolution this year. It's basically a narrative project to explore some of the biggest questions that are facing humanity and how we can hopefully proactively shape what humanity looks like in the future. I see two parallel trend lines today. One, every day there's news about how life on Earth is becoming unsustainable, especially from a climate perspective, but that leads to food insecurity, poverty, pandemics, etc., etc. And it almost feels like every day that, the sky is really going to fall and we may not survive as human race in the near future. And by near future, that may be 100 years, 200 years, I don't know, but we may be living in very, very extreme conditions. The second trend line that I see emerging, and it's happening more and more every day. I don't know about you all, I'm sure, Mariel, it's true for you, but every day I get at least 5 news items about something happening with space. Either, we are reducing the cost of going into space, or we are awarding contracts to build prototypes for housing in space, etc., etc. And it almost feels like a lot of industries felt like as they were in their nascent stages, the internet in the 70s and the 80s, the aviation industry in the 20s and the 30s, the automobile industry before that, the steam engine before that, etc. So it almost feels like, we are at the beginning of something really cool and next. And as I think of these two trend lines, the biggest barrier that I see in a realization of either of these two scenarios, better life on Earth given the crisis, or life in space, is our human bodies are not built for that, right? We are built to live on a terrestrial environment. So to survive as human race, will health technology be the way we will overcome these barriers? And is that the basis of the Fifth Industrial Revolution? So these are the questions we are struggling with, and that's what we will explore with you, given your area of expertise today. Of course, Anthony Pizzonia and Tilman Pitcher, two of my students, are here to listen in, ask questions, and learn from all of us as we all learn from each other today. And with that, let me again, welcome Dr. Borowitz. Dr. Borowitz is, we are really privileged to have her here today. She is an associate professor in the Sam Nunn School of International Affairs at Georgia Tech. And it's very interesting to see someone who's a space policy expert sitting in a School of International Affairs. And we will explore that a little bit more. I understand you talk a lot about your expertise is in space policy, as well as in satellites and how we can use satellite data to make life on Earth, especially climate, better. You have also worked at NASA. And you are really, into this, and you also have a recent book, Open Space, the Global Effort for Open Access to Environmental Satellite Data. What did I miss?
I think you covered it. I also do a little bit of research on the space security side and kind of understanding how we monitor debris in space and some of those issues as well. But yeah, a lot of it is on Earth observations, international cooperation in these areas. So I think you really touched on all of that.
Yeah, and those are great topics. We'll get into international cooperation and satellites and all of that good stuff in a minute. But before that, what made you go into space? I mean, was it something about life on Earth, or why space?
Yeah, so the short answer is that I liked it as a little kid and basically never let go of that idea. Okay. So, but in particular, I really like how many opportunities for answering new questions that there are with space, right? There's so many things we don't know yet, whether it's things related to astrophysics and astronomy and the origin of the universe and things like that, or, even getting more information about the Earth or developing new types of technologies and new rockets and new capabilities. So all of it was always fascinating to me, and I kind of stuck with that. I originally studied aerospace engineering.
Yes,
I love math and science, and yeah, and really enjoy the technical aspect of space. But then kind of gradually switched over to space policy, where we're really grappling with the questions of not just how to build things, but what should we be building, and with whom should we be building it, and what is the larger plan there. So I really like that, that kind of policy perspective as well, and could have stuck with that.
So why are we focused on space? I mean, is it because life on Earth is gonna be bad and the climate crisis is real, or is it just human nature that we're always explorers?
So I think it's both.
Okay.
I think, some of the human exploration stuff we do, there's a international strategic element to it, certainly a geopolitical element, but it's also, just innately exciting to lots and lots of people. And I can tell you, when I first switched from being an aerospace engineer to doing space policy, we had a class where the question of the day was, why do we do human exploration?
Yeah.
Why do we put government money into that?
Yes.
And as a engineer still, just coming in, I was like, I don't even understand the question. Like, of course we have to do that, that it's, it's so exciting. It's so cool. I had really, in years and years of studying space and being excited about space, never asked, never thought that I would have to justify it, which of course you do. So I think there is that. A lot of people who are very excited about it and very, inspired by space activity. But there also is this very practical side of space as well. And that's where a lot of my research has been in recent years, is looking at things like Earth observations, how we cooperate internationally to use those observations, make them available for things like monitoring climate change, that are, extremely practical and important benefit for improving life on Earth.
So you talk about this policy and cooperation. I understand there are treaties now. There is a treaty where 111 countries have signed that space is for all and not for one. So talk to us about how are we, from a global perspective, looking into exploring space? What are the guardrails? What's the vision? How are we really approaching it as planet Earth?
Sure. So there is the Outer Space Treaty is one of our kind of major international agreements, and it says, space is to be used for peaceful purposes. It should be available to all, but it's a pretty high level document.
Framework,
so it doesn't go into a ton of detail. It doesn't really prescribe any specifics of what we do with space. So anything we do beyond that is usually more contemporary partnerships. So in terms of space exploration, human exploration, I think, NASA now has its Artemis program. It's trying to go forward to the moon and then eventually onto Mars. And they're cooperating with Europe, with Japan, to try to make that a reality and try to set up some kind of norms of how you do that. China, of course, at the same time, is also working on a lunar program in cooperation with Russia. So we have that happening kind of on the human side. And it's an interesting time in terms of international cooperation, because there are some kind of changing, compared to what we've had with the International Space Station, there are some kind of changing dynamics there. And then for Earth observations, where I've done a lot of my work, we have pretty good international cooperation in terms of sharing data. So it's, depending how you look at it, about half of the data that's collected or has been collected since the beginning of the space age is made openly available. So it sort of depends if you're a half glass full or half glass empty. Sort of. On the one hand, that's very good. And NASA, for example, makes all of its data, every civil Earth observation satellite we have in the US, data is freely available for anyone online. You just go on, you can use it, anything, start a company, do climate research, anything, which is pretty great, and it makes a big difference. That said, there's about half of the data that still isn't available. It's under some sort of restriction. Either you have to charge to get access to it, or you have to go through some process to request it and be approved, or it's just kind of not easily available. It's not clear how you would go about getting it. And that is a challenge, right? So if you're trying to monitor climate change, for example, we have there's a group called the Global Climate Observing System, GCOS, and they identified 50 essential climate variables, and about half of them are best collected by satellites.
Okay.
But if you look at all of those variables, we're not collecting all of that yet. So we're not collecting all the things that scientists think are essential. And even among the stuff we are collecting, not all of it is openly available, right? So, if someone's collecting something, that's great, but if they don't share it with anyone else, then it's pretty limited value, from a global perspective. So we have some international cooperation there, but also a ways to go.
Right. What's also interesting is I was just trying to figure out how much every country, invests in space exploration, whether human or Earth. And NASA, it's clear, what their budgets are. We are seeing activity in the private sector. We are at about $5-6 billion last year, 4 billion plus already this year. But when you try to look at global investment, it's very difficult to figure out, who is investing, how much are they investing. So it feels like even though there is this desire to be a global force to explore space, there is a lot of secretive, activity.
So there are a fair number of nations who make their budgets available, and there's a publication called the Space Report done by the Space Foundation, which I used to work for them for a few years when I was in grad school. I'll do some consulting with them, but they put together information about kind of global spending. Some of the big names that are missing are, China, Russia, so where we know they're big players, but they don't make their budgets or their workforce numbers or any of that publicly available. So that is a little bit of a challenge. But for, US, Europe, Japan, they do make their budgets available. The US is much larger. Basically the US budget is kind of the size of everybody else's budget, as far as you can tell. Yeah, and that's just the the budget in the US that we know about, right? So there's the NASA's budget, around I think 20 billion, like you said. But then there's also the military budget, which is even larger than NASA's. And then there's also a classified budget that we don't know how large that is. So.
Oh, wow. Okay, I did not know that. That's so we are spending upwards of $100 billion just in US. Then I could estimate that based on what you said.
That's possible. It's hard. It's hard to know with the classified side, but certainly the US puts a significant amount, more than anyone else in the world by quite a bit.
Yeah, I was just trying to look at revenues of some of the big companies. Walmart 550 billion. In 2020, Apple 275 billion, Exxon 180 billion. So we are spending almost that much money now in space. So that's a big number.
Yeah, I think the number. So in that same report, which I referenced because I'm familiar with it from working on it, they estimate about 400 billion, I believe, in the most recent for kind of global space revenues and budgets.
Wow. So it is serious
it's definitely
stuff.
A growing area, a pretty large area.
Yeah, so it is serious stuff. So let's talk a little bit about, first Earth observation and the satellites. And you talked about we don't share enough data. Other than climate, what are the different uses of these satellites and how can they help make life on Earth better?
Yeah, absolutely. Well, so I think, it depends how you classify things, because a lot of stuff, as you mentioned in the beginning, is climate related. So one of the uses I would say that is really important is for disasters. Satellites are really important when disasters occur, because you can get, imagery from before and after. You can see where flooding's occurring. You can see, of course, weather relies very heavily on satellites. So our forecasting is heavily reliant on that. And so I think that's a hugely important application of satellites. Wildfires are also, you think that they're that huge range, a lot of times it's sparsely populated areas. So satellites are really important for that mission. We use them for a lot of agricultural purposes. So USDA uses that data and tries to look at globally what's happening with agriculture and try to make some predictions there. The solar industry uses satellite data to try to understand kind of where best to locate solar collection.
Not my roof, not again on my roof.
So there are so many different applications, and I think a lot of the environmental ones have at least some tie to climate change, right? But you can also break it into these really specific, and urban stuff as well. I've seen projects looking at urban heat islands and trying to really understand, or I saw a project just recently where they were using Landsat data to do a tree survey. I think it was in Chicago, and trying to really understand where in the city, are all the trees located? If they're going to plant new trees, how can they do that in an equitable way? Things like that just would be, very hard and time consuming to do that kind of survey on the ground. But when they have a satellite image of the city, and, especially now with some of the AI capabilities or machine learning capabilities, you can do that really quite quickly. And so there's lots of applications and lots of new ones coming up constantly. That's where I think a lot of the growth is happening.
Yeah, I mean, telecommunications has always been there, and climate, like you said, solar, urban areas. What else? You said a lot of other new applications. What are some of the innovations you are seeing?
Yeah, I'm trying to think of examples. So like this tree one, I think, was an interesting one. There's, I worked on a project recently where we're looking at the Gates Foundation worked with the Global Polio Eradication Initiative to use maps in Nigeria to help better understand where the population was located, because they haven't done a census in like 15 years or so, because they were trying to do polio vaccination campaigns. But in order to be effective at that, you need to know exactly where people are. And there were no good maps that really showed exactly where the settlements were and how many people in them. And so people were getting missed, whole settlements were not getting access to these vaccines. And with satellite data, they were able to make much better maps to geotag them to actually make sure that everyone was getting the opportunity to get that access to that. So kind of interesting healthcare application there, right? That, and they've used actually very similar data now for other things like building new schools, figuring out where to drill wells, right? Because they want to make sure that they're equidistant to different communities. So so that's another kind of interesting one. But it feels to me like every day I'm seeing, a new story of some interesting application like that.
Very interesting. So is it fair to say, or am I minimizing by saying that satellites are being used to map and collect every data point possible for Earth and then see how we can use that to make life better? Just it's data analysis of images and other data we are collecting.
So they are collecting a lot of data. We have, imagery at different kind of spatial scales. We have, there's radar data that can collect data even at night or in the rain. We have data, satellites that collect information about the atmosphere rather than the ground, right? So instead of imagery, we're looking at aerosols or other things in the air. So there's lots of different data. I won't say everything because, like I mentioned earlier, there are variables that we know we'd like to know more about to understand climate change that we're not collecting. So there's a lot of data, and I think we're still figuring out how to best use the data we have. And there's, a lot of science. They talk about science coming from the archives with some of the satellite data, because we're finding new ways to use the data that we already have collected in the past and are collecting now. So there's that happening, and that's still, just the tip of the iceberg, I think, in terms of using the data we have. But there also are opportunities where if we could collect more data and more types of data, there are other applications that we could do as well. So it's interesting. It's on both sides.
Yeah, and I'm sure, once we get into edge computing, a lot of those calculations will become much faster as well, and that will also accelerate.
And the space agencies, so NASA, NOAA, who does the weather satellites, and USGS, who runs the Landsat system, they're all moving their data to the cloud and have actually started to do that already, which is, again, changing what's possible for scientists, because now you don't have to download gigabytes, petabytes of data, right? You can just go on and use it. So that's changing what's possible.
So are we hearing from aliens as we have these satellites out there?
Not yet. So we still do have the SETI Institute, which originally started as a NASA program back in the 70s, and now it's a nonprofit, and they do still listen for radio signals. But
I think of Contact, Jodie Foster, and what I've heard is that computing power has increased so much that by 2025, we will be able to discover alien life. And by alien life, it does not mean a green person walking, but it could be, microbe or something.
Yeah.
What do you think? Are we there?
So we're working on it. I think the two big directions, and actually there's at least at one point was a kind of internal friendly bet within NASA science about whether it was going to be the astrophysics directorate, who is looking at exoplanets around other stars and trying to find habitable planets there, and if they could find signatures of life, or if it's going to be planetary science, who's trying to build missions to go to places like Europa, where we know there is a water ocean underneath this ice, and could we find microbial life there, or in Enceladus or one of these other places within our own solar system. So nobody has won the bet yet, but I think people are definitely watching that carefully.
Okay, good. So let me switch gears. I mean, we talked about satellites, the data, types of data they may be collecting and maybe not, and how you are seeing the applications of the data really diversifying from just, weather patterns. I would say that's what, about 75% of focus of space exploration right now, how we can collect data on Earth and make life better on Earth, or is it 50% and 50% is space for space purposes?
Oh, that's a good question. I believe within NASA, the Science Mission Directorate has the largest portion of the budget, but within science, Earth science is only one of four things. So there's Earth science, planetary science, astrophysics, and heliophysics. So I think that Earth science piece is just is not the majority of NASA, certainly. I'd have to look up the exact numbers again, but it's just one portion. Exploration is probably the other big chunk of what NASA does. So the exploration budget, especially if you combine that with planetary and astrophysics, that's going to be much larger than what we spend on Earth science. In Europe, it's a little bit different. I think in Europe, the spending on their kind of Earth science program is about equal to their spending on the rest of space science and exploration. So it varies by location. And a lot of countries, so definitely the US, Japan, China, the European nations have pretty big budgets for Earth observation. So they're all putting, maybe not a majority of their funding, but a significant portion of their funding towards Earth observations.
Okay. So it's just not about Earth anymore. It is about space, really, as well.
Yes. So I think the Earth science budget, it's gone up and down over time, but it's, overall, I think it's probably grown since early in the space age. I think there, especially following sort of the Apollo era, there was a recognition that space is very useful for learning about the Earth. And in fact, there was a time when, we knew more in some ways about other planets in the solar system than we did about Earth. That we were, studying Venus as a whole system or Mars as a whole system, but had not really thought about Earth in that way. And so there was a proposal from NASA in the early 70s to say, no, let's think of Earth like we think about Venus and try to understand it as a whole Earth system, rather than as, geology and these separate pieces. And so that I think really spurred this idea of Earth science, and that has grown over time. But exploration is still a big piece. Yeah.
So I read the term LEO, L-E-O. What is LEO?
LEO is low Earth orbit. Most of our satellites that are doing these Earth observations and things, most of those are in low Earth orbit. We have a few satellites, particularly a couple of the weather satellites that are in GEO, which is geosynchronous Earth orbit. And those are the ones that they're in orbit that makes them seem like they're staying, stationary over one. So we have like a weather satellite that sits over the East Coast and sits over the West Coast and watches for hurricanes, for example.
So you said that beyond LEO, there are only 4 possibilities you see in space exploration right now, and you talk about them as cislunar habitat, asteroid redirect, so basically making sure asteroid doesn't hit us, Mars flyby, and a short lunar surface sortie. So let's talk about these 4. What do you mean, and then why just these 4? Why not something more?
Sure. So I think this is related to an article I wrote a few years ago with Jonathan Batat. So I want to also give him credit as the co-author. Yeah, so what we were trying to look at is, if you look at the state of technology globally and what the capabilities are among governments and kind of the commercial entities that work with governments, what is a reasonable next step? So not just thinking about kind of long-term goals. Yeah, we all want to go to Mars eventually, but what can we actually do in the next 5 to 10 years with the technology we have and kind of a reasonable level of development? And so by doing these kind of,
the time frame is 5 to 10 years.
Yeah, approximately.
Okay.
So it's meant to be kind of the next step. So not a final,
not a 30-year
end destination, but what can we do in a relatively near term?
Mm-hmm.
And so through interviews and working with some of these entities, what we came up with is the list you just mentioned. And basically the idea is, there are people who advocate for, well, let's just go straight to Mars and have a habitat on Mars, but there's so much new technology that would need to be developed to do that, not the least of which is the health technology that you mentioned, right? Those Mars missions are multi-year missions with humans. There's just a lot of technology that needs to be developed. And so were you to do that as your next step, you would have a long period, a decade, more than a decade probably, of technology development before you'd see any real results. Whereas with some of these other missions like a cislunar habitat, which NASA is basically building right now, right? They're building the new station that'll be a cislunar station, or an asteroid redirect mission. This was actually one that NASA talked about close to 10 years ago, I would say now, where they would actually bring an asteroid closer to the Earth and send astronauts to go visit an asteroid rather than going to the moon. So these are things where our technology is close enough that we could probably do that as a next step. So what the international community has really settled on, this lunar orbiting platform, the station that's going to be near the moon, and then also a moon settlement. So that was kind of the decision in terms of where we're going, and that does align well with kind of what we determined in that paper is a practical next step, where you're really going to be able to see results in a reasonable amount of time.
Right. I was reading somewhere about Prospector that there's a company that's deep space exploration, I think, and they're trying to send these robots onto asteroids that are near Earth and mine for minerals there. Is that science fiction? Is that real?
So it's not science fiction. There are definitely entities that want to do that. I think long-term, both on the moon and for asteroids, we probably will do some, they call it in situ resource utilization, right? Using the material that's there for some purposes. With the asteroid mining companies, they did run into trouble from a commercial perspective, right? Because the technology is not quite there yet to actually get there, do the mining, but also the economics are not there, right? So while in theory there's a lot of valuable metals, there's also potentially water that you can get there, which would be helpful for exploration. But the cost of getting it right now is so much higher than what we have on Earth that it just doesn't make economic sense yet. Right. But there are definitely people who are further developing those concepts, developing those technologies to try to get there at some point. So I think we will see that eventually, but still a ways off.
What is interesting is if we think of the lunar base that you just talked about, right? The idea is that is the first habitation, and then that will act as the pivot point or the launch point for further exploration. Now, if I think back to just our life on planet Earth, I can think of 3 scenarios and tell me which one is more realistic from space perspective. So one scenario is we built the base camp for Mount Everest, and not every year a few people go up Mount Everest and come down, but we don't look at how we build settlements on the top of Mount Everest, right? So it's just a little bit of curiosity, a little bit of, we have done it kind of a situation. Antarctica, we went through a lot of exploration. We got there, we have a station there, but we, have left it. It's of no value and we don't do much of it anymore. Or Columbus or Vasco da Gama left Portugal and Spain, and we found America, we found India, and the world just became a very different place. So which scenario is this lunar station? Is it Vasco da Gama and Columbus? Is it, curiosity?
Yeah.
Let's see where it goes.
This is the $1 million question.
Yeah, I thought you had the crystal ball.
Yeah, I know. Yeah, and we don't have a clear answer yet. I mean, I think at one point I would have guessed, and I think the early stuff might be like somewhere between Everest and Antarctica, right? Where we want to go there, we want to do research, that kind of thing. But there are valuable resources on the moon, right? And they're not equally distributed around the moon. So there are places where we think there's water ice, right? Or we know there's water ice. We don't know exactly how much. There are different kind of minerals that are potentially useful on the moon. And so I don't know. I think it's a question of, both the technology and the policy. So how quickly can we develop the technology to actually utilize that water, right? In theory, you could collect that water, you could use it for drinking water, you could pull it apart into its constituent parts, use it for fuel. So there's some pretty interesting possibilities just with the water. Then there's the minerals that are, in the lunar regolith and the lunar soil, essentially, that also could be used. You could manufacture things with that. So if we get the technology to make that possible, the timeline for that, then maybe you're talking about closer to, the discovering the Americas, right? Getting something where there's really a lot of resources. And, how much does the commercial infrastructure build up in the meantime, right? So now we're seeing some human tourism, some
Yes.
more activity in orbit. And as that starts to get larger, right, then that also drives demand for some of these resources.
Innovations and technology, yeah.
Right. And so I think it's, how fast does that move? And then what's happening on the policy side? Is this something like Antarctica where we have pretty good global agreements? We have, everybody has their station, they, respect each other and the locations, or is it going to be a, sort of gold rush, see who gets there first, get the most, strategically valuable area. And that's, undetermined right now.
Is there a trigger that you can think of that would move it more in, it should be supercharged, the exploration? Is there a trigger in terms of life on Earth becoming worse? Is there a greed trigger? Can you foresee some triggers?
Yeah. So I think there are probably two things, again, on the technology side or the international relations side. So one is if that technology has sort of a breakthrough and someone starts to demonstrate, I'm pulling up water, I'm able to use the water, I'm making my own fuel on the moon. I think there are a lot of people who kind of don't realize those resources are there right now. And they think of the moon as a nice, like, place to put your flag, like, good for us country, but not as a place where there are resources. So I think if someone starts to really demonstrate that, I think that might get some people in Congress and the public thinking, oh, well, if there are resources, we want to be where the resources are. And then I think also on the kind of international competition side, right? So the US is planning these lunar missions, but as I mentioned, China and Russia are also planning lunar missions. And to the extent that, these resources are not evenly distributed, if other countries, depending on who gets there first, who gets these kind of best locations potentially, that might drive some desire to say, like, okay, wait a minute, we don't want to be left behind. We want to be a part of this. We want to, be one of the players there. So I can see either one of those happening.
Yeah, I mean, the 60s saw the space race, and that's how we got so many lunar landings and everything. So absolutely. Competition is a big driver. Greed is a big driver too. So let's see if greed wins or competition wins this time. Wonderful. So one more question, and then I want to hand it over to Anthony and Tillman, because we also want to respect your time. So initially I talked about our thesis and this whole idea of, health. If I'm right, we have sent only about 600 people into space so far. Actually, that's about right. Yeah. Right. And those 600 have health like an Olympian does. So if we are going to make lunar landing and settlement reality, and let's just talk moon right now, let's even go to Mars, we do need to make advancements in health. So from where you sit, do you see a lot of activity in the space of health for life in space?
Yeah, so there definitely is. I mean, there are people working on it. when I was an undergraduate, I actually interned in the Office of Biological and Physical Research at NASA, where they were doing some of this, trying to understand how humans are affected by space. And there are a lot of things that change. Your heart is affected, the way your circulatory system works in general is affected. All sorts of. Your muscle, you lose muscle relatively quickly. Your vestibular system changes. So. There are a lot of issues that they are at least aware of, but are still kind of working through how you deal with those, how you do kind of exercises or other things that are countermeasures. When you talk about being in space longer term, the radiation issues are really significant. Particularly, the sun, there's a solar cycle where it has more or less activity. So during those high activity part of the solar cycle, that is particularly worrisome. So there's a lot that we know is a challenge, and there are people working on it. But I think there's a long way to go. I have a good friend of mine actually that's does space medicine as an ER doctor, but now is working at NASA on these types of issues. But I think that community is still a relatively small group.
Yeah, can we talk to him?
Yeah, absolutely. I'll put you in touch.
Wonderful. Yes, I mean we have heard of initiatives that are happening with SpaceX, where they are looking at health in space. There are some competitions that we are seeing being launched, but we have tried to figure out where to reach out to understand what's happening, and then not finding many people. So would really appreciate a connect with your friend. With that, Anthony Tillman, what's on your mind?
So Dr. Borowitz, first and foremost, I just want to thank you for taking the time to appear on the show. I think I can speak for all of us and as our audience as well when I say that we learned a lot today. But one of the things, of course. One of the things that I kind of wanted to pivot back to is when you talked about classified data as it relates to the budget. So I could go on Google right now and I can look up the U.S. national deficit. I can look up discretionary spending, military spending, all of these things. But it kind of raised a bit of like a red flag in my head when you mentioned a classified budget. So I was just wondering, what do you think these countries are hiding as it relates to that?
Yeah, well, I mean, to be fair, I think that the country with the largest classified space budget is going to be the U.S. Probably by quite a bit, right? So, but the military puts out a fair amount of information about what we're doing in space. But we know, for example, the National Reconnaissance Office, has these launches on a fairly regular basis, and they don't say kind of anything beyond this is NRO satellite 71, right? So all that development, exactly what they're doing, what those satellites are capable of, how much they cost, that's all classified. There's also some, the Space Force has talked about having some, active defense or space control capabilities. Those sorts of developments and those technologies are typically classified. So we have like a general sense of the types of things that are probably found in that budget, but of course we can't be sure, and the size of that budget is a question.
Yeah, and just to follow up on that too, real quick, do you foresee like a lack of data transparency being a cause for like a global conflict, or is it just kind of something everyone has and it just is what it is?
Yeah, no, this is a really good question. So I think in terms of, budgets and things like that, certainly we'd like to have more data, but on a more general level, understanding what countries' intentions are in space, what kinds of things they're trying to develop, what their view and goals are for space, I think is a really important area of transparency that we could do a lot better on. So, with, you just think of the US and China and Russia, for example. There's a lot of trying to look over at what someone else is doing and trying to understand, well, why are they doing that? Why are they developing that capability? Is that are they developing something that can move close to a satellite because they want to inspect their own satellites and be able to repair them? Or are they building that because they want to inspect someone else's satellites and destroy them? Right? That's the same technology. And it really just comes down to, your intentions and your plans. And so the more transparency and the more, getting people together and allowing them to know their counterparts, have those discussions, the better, in my view. And there is some work happening on that. There's the UN Committee on Peaceful Uses of Outer Space, where they are looking at, long-term guidelines for sustainability and confidence building, transparency and confidence building measures, things like that. But there's a lot more we could do there. And I think, to the extent that we don't do that, that is a challenge. You could have misunderstandings and that could lead to conflict.
Thank you.
Mm-hmm.
So Dr. Borowitz, also, thank you so much for coming on. It was a pleasure. This was an awesome episode. So I want to bring up, it was actually pretty fortuitous that you brought up the URO Satellite 71, just as a for instance, because my question is, do you foresee any problems as we get a lot better at sending satellites up and collecting data with those satellites, any potential for infringement of privacy as the technology sort of outruns the legislature and there is no real rules around this stuff yet? Do you foresee something like that being a problem?
Yeah, it's interesting. So we've had, commercial remote sensing capabilities since the early 2000s. So, for 20 years, there have been companies that are out collecting right now. Legally in the US, they are allowed to collect data down to about 30 centimeter resolution. So they actually could do even better than that. They have the technical capability, but there are some laws and regulations that limit that. So that's right now 30 centimeters is the limit that they're allowed to sell. But that's still pretty, that's a pretty small.
Right, and that's the
area.
the commercial satellites, right? Because now you think about the secret budget,
and you're wondering,
are they following their 30 centimeter rule? I don't suspect.
Yeah, no, certainly not. So yeah, the reconnaissance satellites, there are no limits as far as I know on what they can collect. They do, at least in the US, there are policies about collecting data, like those satellites or reconnaissance satellites are collecting data of other parts of the world as opposed to of the US. And there are some internal rules in the government about that. But yeah, I think this question of privacy, for a long time, it wasn't a big area of debate because we just weren't collecting, at least in the publicly available data, weren't collecting anything that got down to that level. But now we are starting to see that, that the data that people are collecting and actually putting out there or making commercially available is starting to be on the edge of, well, I can see your specific house, I can see where your car is, moving, especially because, you have that high spatial resolution, we see that 30 centimeters. But the other thing that's being developed now is very high temporal resolution, meaning you can view the same spot, every day, as opposed to with these very high resolution spatial resolution ones, it was kind of every couple weeks or every, maybe few days if you were lucky. But now Planet, for example, is a company that's doing this very high revisit rate. And has new questions, right? Because now this thing I'm saying about, well, let's watch where your car is going, or watch where, when you're home and when you're not, or things like that are potentially available. So yeah, I think that debate is just starting to happen. It's relatively new for this community because for so long the data was, not that high resolution, and there just weren't that many kind of privacy issues that could come up. But yeah, we'll have to see where it goes, because I think we're just at the beginning of that.
Thank you. Yes, I think so too. I think that's going to be a big conversation here in the future, because I know my inclinations, and I'm like, I didn't ask for a satellite to be up there taking pictures of me, and it is. So it does concern me as much as I love the technology.
Yeah, and there are already, I think there was a legal case a number of years ago where the just with the Google Earth imagery, which is based on satellite data, there was a case where somebody was growing something illegal in their backyard, and some of the law enforcement found an image of it on Google Earth and said, well, there's some proof. So is that allowed, right?
Yeah.
So that's some interesting questions. So they're still being worked out.
Yeah, very, very interesting. This is a topic we can spend entire weekend, a few months on, but I know we are limited on time. So let me just wrap up with, one question. We started out with a thesis, right, of the Fifth Industrial Revolution, the two trend lines: space, life on Earth, potentially health technology enabling both. Now that we have talked about space, what is your forecast on the Fifth Industrial Revolution? Will it be about space? Or will it be about life on Earth? Or will it be about finding technologies in space that can make life better on Earth? Or is it about health?
Yeah.
Or something else?
That's a good question. So I think that there is we are on the edge of a lot of activity happening in space, and a lot of new activity. And I think that's going to be, partially focused out, right, and looking at these resources and all that. But I think there's going to be a lot that's focused in. I think we're collecting new data, new types of data. The revolution in terms of computing capability and analysis is just going to have such a huge impact on that as well. So I think that impact, what space can do for the Earth, is going to be a really big one in the coming years.
Wonderful, wonderful. Anything else? Any thing we missed we should have asked you?
I don't think so. I think we've covered a lot of area, but it's been a really interesting conversation. And yeah, thank you for having me on.
Wonderful. Thank you so much for your time again. Really a pleasure. And we will follow up. Again, thank you so much. Very, very enlightening today.
Wonderful. Thank you.
All right. Thanks. Bye. Wow. A lot happening in space. $400 billion. That's quite a bit of money to put into an effort at a global scale. And you know what? When you're putting that much money, we are going to see more activity. A very, very interesting conversation with Dr. Borowitz today, and a lot of things to think about. Yes, looks like space exploration is a lot about how we can improve life on Earth right now, and that's the near-term future. But we also talked about how technology is advancing, and once we are on Moon, knowing the human race, there's no stopping us. So more to come on this. We'll be talking to more people about other challenges, policy issues, innovations in space, and health as well. So stay tuned. Thank you for watching. Bye-bye.